Let's focus first of all on if we had n identical looking coins, one is fake and all the rest are real and the fake one's heavier, if we're only allowed to make one comparison rather than two. So for this, if we had like obviously if we had one coin, we could tell it because that one must be fake. If we had two coins, then we could put them on the scales and we'd see the one that goes down would be the fake one. What if we had three? Well, we could again compare two, but put one on the side. Because now, if the fake one's on the pan, then the pan will go down. And if the fake one is at the side, then the pan will be balanced. And because we know there's a fake one, then we can also identify it. Now, if we had four, then actually this would be too many to be able to identify. Because if we only compared one at a time, then you could end up with this scenario, for example, the fake one's on the side, but we can't tell. So three is good. We can't tell which one the fake one is. If you try and compare two in one go, then you're going to end up with the fake one somewhere, and this is going to go down. But again, you can't tell which of the two is fake with this one comparison. So overall, just to start this problem off, because we're not finished, but it's going to basically set the tone. If we have three coins and one of them is fake, we can identify the fake one, but four, we can't. Okay, so what if we can make two comparisons? It's worth just actually thinking, can we do it with nine coins? Because then if we can, at least with this multiple choice part of the problem, we know that would be the greatest. So nine coins, one of which is fake. Now let's imagine that the fake coin ends up on the scale. Okay, so if we go with groups of three, and then there'll be a group of three here, then this would tell us that the pan on the left has the fake coin. We'd then be left with three coins and then we can do the next comparison with three coins, which we know is possible. So if the fake coin ends up on the scales, we're okay. Now, what if the fake coin doesn't end up on the scales? Then it's going to be outside, and now the scales would balance, which would tell us that the fake coin has to be in this pile. So what I'm trying to get at is it's definitely going to be the case that 9 is possible. So just to summarize again, okay, we've got three groups of three. The fake coin is going to be in one of the groups. If that fake coin ends up on the scales, we can identify it's this group. And then we can do a second comparison, just like I showed up here with the three. So just test out of the three that we've now got, just test one against another one. If the fake coin's on the scale, it will go down. If it's not on the scale, they'll remain balanced. If the fake coin doesn't get put on the scale originally, then the scale will be balanced. But again, we'll identify that it must be in the three that weren't used and then repeat the process. So that must be the answer. E, it's 9. We should just probably think about why 10 is not possible, and we're going to run into the same kind of problem as before. So if you had 10 coins, okay, what do you do? Well, you know, we know that in a second comparison, we can have at most three left. So we need to get down to three. But as soon as you start comparing three like this, then we're going to have a group of four outside, for example, with the fake coin. And then it's not going to be possible to distinguish with four. So that means we're going to have to put more than three on the scales. But then if we put more than three on the scales, for example, four, you're going to have to put four on both, then now this one will go down, but then you're going to be left with four here, where we know that's too many to be able to necessarily distinguish it. So hopefully I've justified why 10 is too many, even though it's not on the multiple choice. I'm just trying to explain it anyway, just, for future problems where you might be expected to extend this potentially for like 3 comparisons, 4 comparisons, and so on. But we look at the highest number on the multiple choice list, and I have justified why that one is possible, and that's our answer, and I've also explained why 10 is not okay. All right, really nice question. I mean, I have seen questions like this before. They're really interesting, I think, so I hope you enjoyed that one as well.